Hi folks, Chris McClure. We're going to continue talking about solving algebraic equations. In particular, we're going to look at equations involving radicals, equations that are quadratic in form, but those expressions are not necessarily just x's, but maybe some functions of x. We'll also talk about factorable equations. So first of all, radical equation. So a radical equation is an equation that involves, you guessed it, a radical. Like, for example, this one right here. We'll look at some examples of how to do the solution process for an equation involving a radical. Now, if you have cube root of 3x minus 1 minus 2 equals 0, then what you're going to want to do is to get the radical to one side of the equation and everything else to the other side. In this case, we're going to add 2 to both sides. And then, this being a cube root, the inverse operation of cube root is cubing. So we will take the cube root of both sides, we'll take the third power of both sides. We will cube both sides. Now on the left-hand side, when you raise the cube root to the third power, that's just going to cancel the cube root, leaving you just with 3x minus 1. 2 cubed on the right-hand side is 8. And then this is a more recognizable equation. Add 1 to both sides, divide by 3. And you have your solution. Now, you might want to double check. You could do this by inspection. Plug in 3 for x. 3 times 3 is 9. 9 minus 1 is 8. Cube root of 8 is 2. 2 minus 2 is 0. So yes, indeed, 3 is the solution set for this equation. All right, moving along here. Here we've got this equation here. We have the radical on the left-hand side, so we'll square both sides of the equation. And now this is just a more recognizable quadratic equation that we'll use, or that we'll solve. And now, when you get to this point where you come up with numbers that are potential solutions, you're going to want to check. Plug in 0 for x into the original equation up here, and you see that the equation checks out. But when you plug in 3 for x, you end up with, the square root of 3 plus 1 is 2. And on the right-hand side, negative 3 plus 1 is negative 2, so the equation isn't true. So that one is not going to be the solution, or a solution. So 3 is what we call an extraneous solution. So we have one element in the solution set, and that's going to be the 0. So 0 is the solution to the equation. Okay, moving along here. Yep, here we have an equation involving 2 radicals. Well, the ideal here is to get one radical by itself on one side of the equation and the other radical along with everything else on the other side. In this case, we'll add square root of x to the other side and then square both sides. FOIL out the right-hand side. Subtract x from both sides, subtract 1 from both sides, divide both sides by 2, square both sides, and then that's a quadratic equation that you know how to solve, maybe by factoring in this case. Again, I will impress upon you the necessity of checking both of those solutions to verify they are solutions. Notice that the 1/4 does not solve the equation, so that's an extraneous solution. But when you plug in 1, that does solve it. So we have the solution of 1. So double check those solutions to verify that they really are solutions. Now, when we talk about equations quadratic in form, this is what we're talking about. But instead of x, we have x minus 2. All right, so you can solve this by doing a little substitution. Let, some other letter of the alphabet, like U, be equal to x minus 2. And then that gives you this expression here, this equation. And then solve for U. Okay, and then if U is equal to 2 or U equals 1, that means that x minus 2 is equal to 2 or x minus 2 is equal to 1. And then add 2 or add, to both sides, so you have x equals 4 and x equals 3. Check both of those answers if you want. They do check out, so 3 and 4 are the solutions. The hardest part about this one is to make sure that when you get down to here, to not declare 1 and 2 as solutions, but to re-substitute, as in back substitute the x minus 2 in for U, and to solve for the original variable, x in this case. Alright, here's another equation. Now you could take this equation, solve for square root of x, by subtracting 6 and subtracting x to the other side of the equation, and then dividing by -5, and then squaring both sides, and so forth. But there's an easier way to solve this. Just recognize that this equation is quadratic with the variable being square root of x. So you could do a substitution, let u be equal to square root of x. Then you have that equation there, easily solved for u, and then solve for square root of x. Sorry, substitute square root of x in for u. And then you got your two solutions there. Now, if you would have came up for u with any numbers that are negative, if any of these solutions for u were negative, then it doesn't make sense for square root of x to be equal to a negative number, so that would have been an extraneous solution. Solve equations by factoring here. Well, this goes beyond just a quadratic equation where you have a second order polynomial or a second degree polynomial. Here in this case you have a third degree polynomial, so what you have to do is try to factor it as best as you can. We're lucky in that this third degree polynomial that you see right here has a factor of x that we can factor right out, and then we have x squared minus x minus 2, which factors as x minus 2 times x plus 1. So you have x times x minus 2 times x plus 1 equals 0. Set those three factors equal to 0 and solve for x, and you get these three solutions right here. Here's another example here. Now, when you have a third degree polynomial set equal to 0, one thing that you could try to do is to factor by grouping. You can take a look at these first two terms, factor out an x squared. Look at the second two terms, the third and fourth term, factor out a -4. And in both cases, you'll end up with a factor of x minus 3. That's a good thing. Now you can factor out that x minus 3, leaving you with an x squared minus 4, which, by the way, you can factor. So now you have three binomial factors, and you can set each of them equal to 0 and solve for x. Okay? So now you have your solution set. So that is it for today. A nice easy discussion on factoring and solving equations. Alright, so we'll talk about solving inequality sorts of statements next time. Okay folks, have a good Thursday, and I'll see you next time.